I think I've at least peeked over every shoulder, and I've seen this a lot. This is the right answer as far as factoring that. 5 parentheses 4x minus 1. Is that good? Okay, let's try one more. No. We're just warming up for some factoring stuff. Here we go.
We have to find Dr. Jackson.
Oh my gosh. That's hilarious.
Ready, go. Say again.
I know.
No, you can retake something all the way up until business lunch on Thursday. Really, yeah.
I can't think.
Business lunch today? Yeah, for sure. Okay, we're trying to factor that.
No, I got all of that. It makes me happy. It makes me happy. It makes me happy. You should come to the why don't you unsplit? It was actually negative. How'd you get negative? Because there's a minus sign. Oh. No, there's only he tried to come to
I did not try. I was trying to take a half the lane. Going
you got different
outside.
answers going like that. Why is that a negative?
Oh my gosh. The second one, you were like screaming. I don't know. She was like screaming the whole time.
I held one note for Patty.
I held it for like a third.
We held it for like 2 seconds and then I.
That's not true.
I don't know. Okay, I get See, this is why you write it completely out, guys. Show your work. Haven't you learned anything from elementary school? No, I haven't. And then John on the frozen lake.
Oh yeah, there was the launch and there was I went on the frozen part and
When you
ran
slid
and I slid
into the water.
That was not even slick. That was just water. That was like pure water. Well, and then it was
I like part of me really wanted to. Yeah. Guys, what? So this past weekend, I was up at a. That was pretty great. Hey, that was your fault. Okay, you got team over because you tried to cut us off. It's like he's like leaving it out. It's so thick on the inside, and then you turned and we just hit you. Okay, but Josh was mean. Josh was like ready to flip off these 2 girls. He pulls up next to him. He's like,
I pull up next to them. I was like this. You want to go? Let's go.
And then their dad. They were mean.
Really?
And we took that one. That lady, Kyrie, the lady. Is that the guy that I need to be? I was like, we need to get out of here. Kyrie, do you remember the lady? I was so done with her. I just like completely bypassed her. I was like, sorry, lady, we're not gonna do it. And this lady, she's like, I hope you guys can sleep tonight, knowing that you cut these poor children in line. But you guys have to go in line for your cricket creek? No, this is for like an XD experience. We were in line, and 3 of us had to get out of line to go and like get a refund on something, and we came back, and the lady behind us was like, how dare you cut me? I have 5 children.
She had over 10 children. I counted.
She's like telling them don't grow up to be like that. Look at that. And I was like, my mom was
Wow, that's pretty great.
I feel like if you put on 3D glasses, that it would all like come out of the board. What did you even do?
Smile. Smack that smiles back. Cool.
The snack that smiles
Snack that smiles
Callie
back.
yesterday was texting me during her dinner.
Wait. She said Callie, the snack that smiles back. My H. Your A's look like H's.
Keep at it. Okay, so 3x times x minus 8.
Yeah.
We're looking good. Okay, sweet.
Can we do
Well, I only crushed the second.
Not today.
Because someone.
Well, we'll do a lot more factoring stuff like this today, but not these specific ones. Okay, so there's your answer. 3x parentheses x minus 8. So please return to your seats. Grab your notes. We're going to do a little work with factoring today.
Brian.
Has anyone ever heard of that term? Quadratic? Okay. So, those of you that have heard of it, but maybe you don't remember what it is, those of you that have never heard of it, let's talk about what it is. A quadratic, the standard form of a quadratic is this. A times x squared plus b times x plus c, where a, b, and c are constants, right? So they're just numbers. So an example that might be a little bit easier to understand would be, 3x squared plus 8x minus 22, right? So that would be more of the quadratics that we would typically look at. We're just going to look at how to deal with those, how to factor them. Later on, we'll talk about how to solve them. We'll talk about why you'd want to solve them, things you could do with them. But it's important for us to understand what is a quadratic, because in the future, I'm going to say, hey, you've got a quadratic, and I would like for you to have some sense of what that actually is. So let's do this real quick. In the blue example that I wrote up there, what would you guys say the C value is? Negative 22, right? What about the A value? So the A is just the 3, right? Like it's ax squared. So if we've got ax squared as our framework, and I've got 3x squared for that lead term there, the A is 3. The whole first term is definitely 3x squared, but the A is just a number, in this case 3. Make sense? Yeah, Joe?
So do you use the base as the A then, always? Or?
Well, so it's just I would probably use the word coefficient. So the coefficient on x squared is your A.
Gotcha. So if it was like 3 squared, would 3 squared be the whole A?
Yeah, if it was 3 squared, your A would be 9.
Okay.
Yep. But right now the 3 is just to the first power, so
Right.
the A would be 3.
Okay.
Okay, and then what's your B on my blue quadratic? It would just be 8. Okay, does that make sense?
Mm-hmm.
Okay, so for today, we're going to focus on quadratics whose A value is only 1. Now tomorrow and other days, we'll say, what happens if A is not 1? What if A is like a 2 or a 5 or whatever? Okay, so today we're going to only focus on how do we work with these if A is 1, specifically 1. Change it up in the coming days. Does that make sense? All right, so again, just want to emphasize to you all, factoring quadratics has been done to death. It's been done for eons. Lots of ways to do them. I know some really tricky, cutesy ways. I know some like really fundamental, like understanding what's going on sort of ways. And so after 20 years of doing this is kind of where I've landed right now. And this seems to work pretty well. And it's the box graphic organizer, being consistent with what we've done. So check this out. We're gonna take a look at this first one here. It says factor. And I thought I'd do this one with you. And once I've done this one, I'm going to have you guys go and try and see what you can do. And hopefully it'll go really well for you. But if it doesn't, just know we'll keep practicing. So here we go. It says factor x squared plus 7x plus 10. So step one, do you guys recognize that it's a quadratic? Ax squared plus bx plus c. Okay. So if you've got a quadratic, then the way you're going to factor this is with boxes, and it's going to need to be a 2 by 2 box. Joe.
So what would be the A in this case if we have the X?
1.
squared? Okay.
Right? The coefficient, if there's no coefficient, it's understood to be a 1. Yep. Good question. And today we're going to focus only on these.
Okay.
Tomorrow it's going to be what if A is 5? And we'll deal with that. Okay, so if you've got a quadratic, that always goes with a 2 by 2 set of boxes. Here we go. Step 1, put your lead term in the upper left box. So that would be, in this case, 1x squared. And then put your c in the lower right box. So what's the c on this one? 10. Okay, so we're going to set it up like this. And then we got to figure out what goes in those other two boxes. And it's going to be related to the b. And here's what we're going to do. I'm going to come off to the side here and just do a little bit of work. I'm going to make just like a little table just to keep myself organized. And I am going to look at that c value. And I'm going to ask myself, which numbers multiply to be, and actually, let me be consistent here. I want to be consistent. In this case, it's just going to be the c value, but technically what I'm always going to be doing here is I'm going to be multiplying a times c to get my number. So we all know that a is 1. So what's a times c on this one? 10, right? Okay. So here's what I'm going to do with that. I'm going to ask myself, what numbers multiply to be ac? We're going to list them all out. So what numbers could I multiply by each other to get 10?
2 and 5.
Start off with the obvious ones. Sure, there we go. 2 times 5. What else?
1 and 10.
1 times 10. There's some other ones that are a little trickier, but there's at least 2 other sets that multiply to be positive 10. Well, order doesn't matter.
Negative.
Yeah, negative times a negative is a positive.
And the same for 1 and 10.
Same with the 1 and the 10. Okay? Do you guys think, are there any other numbers I could multiply together to get a 10? I think we've listed them all out. So here's how you get the other 2 boxes. Look through that list and ask yourself, which of those pairs of factors adds to be the b? 5 and 2. See it? 2 times 5 is 10. But we're trying to match which of those factors adds, right? What plus what gives me my b? So 1 plus 10 is 11. That doesn't match the b. Negative 2 plus negative 5 is negative 7. That doesn't match the b either. These add up to be negative 11. That doesn't match the b, but 2 plus 5 is 7, which matches the b. So what I would do with that is this. That'll give me those 2. And we're 1 step away from finishing. And I'm hoping that eventually, if not already, you could maybe do that in your head. At least for some of these simpler numbers, you could be like, all right, what times what is this? And adds to, oh, okay, there it is, right? So you write it out if you want. I think writing it out is particularly useful, especially if you're not seeing it. But if you could do some of that in your head, I'm totally fine with that. Okay, so now our final step is basically to do what we did yesterday. Let's factor out common factors. So I'll start off by factoring out this direction. What's in common between those 2 boxes? X. Just an x, right? Remember that x squared is really x times x. So there's 1 common x, right? What's in common between those 2 boxes?
2.
Yeah, because 10 is 2 times 5, right? What's in common between, I'll do this in a different color. What's in common between these 2 boxes? X. And what's in common between these 2 boxes? So your factoring would then be x plus 2 times x plus 5. And maybe you can see this. This is exactly reversing what we used to do when we multiplied a binomial times a binomial. You guys remember making a 2 by 2 box when we multiplied stuff like this together? Like the goal was to multiply this times this. Didn't it look exactly the same? All we're doing is reversing that back. Any questions? So you're going to run into some issues potentially here with number 2. You're going to run into some issues maybe with some minus signs possibly. And I'll let you try to sort that out a little bit. I think you can. But then I'll make sure that before we're done with that one, you're good, okay? So please try number 2 using a similar kind of strategy. Okay, ready, go. 1, since we just talked about this, you've got to recognize that that's a quadratic, right? So if that is a quadratic, what's the a value?
1.
Yep. What's the b value? And what's the c value? C value is 12. Okay, so if you recognize that this indeed is a quadratic, quadratics will always factor with a 2x2 box, something like that. Oh, you guys have been missing out on my awesome artwork? Oh, there you go. Okay. So in that box, of course, upper left is your lead term. So x squared should go right there. Lower right is your c term, so the 12 should go there. And then we got to figure out those other 2 boxes. And so to do that, we come off to the side and we figure out what a times c is. What is a times c? Is 1 times 12, right? Which is 12. And we ask ourselves, which numbers, which pairs of numbers multiply to be 12? We want to try to think of all of them. So what struck you? Oh, thanks, Ben. How about 3 times 4? How about negative 3 times negative 4? Right? And what else? How about
2 and 6.
2s and 6s?
-2 and -6.
You got to think of all of them. And we come back around to Ben's idea.
And negative 1.
So for those of you, like as I walked around, I saw some of you that only wrote out like 1 or 2 pairs of numbers and quit. You want to try, you can use your calculator if you need to, but you want to try to capture all of the pairs of numbers that multiply to be AC, in this case 12. And we go through and we ask ourselves, once we have this whole list, we say, okay, which of these adds up to be the B? Well, the B is negative 13. 3 plus 4?
No.
7. Negative 3 plus negative 4?
No.
Negative 7. That doesn't match. But I do see an interesting pattern. The 3 plus 4 was positive, which doesn't match at all, right? But negative 3 plus negative 4 was negative 7. At least I got the positivity, negativity right. So maybe I start to investigate just the negative pairs, right? So I scratch this one off. Negative 2 plus negative 6 is negative 8. I'm getting closer. And then I finally get down to this one and I realize that's the one that works, right? So then I'm going to write down here, negative 1x, negative 12x. Having that positivity, negativity correct in your boxes will make a big difference for you. So please do take the time to get the right pairs of factors. Once we've done this, we are going to factor out, just like we've done before. So I'm going to factor out this way. If I do, what's in common? X. Please notice here that as I factor, the direction I think matters. As I factor from right to left, please notice that that finishing box, the x squared, is positive. So I'm going to factor out a positive x. In contrast, when I factor out this way, what's in common? Just a 1, but realize that that finishing box is negative, so we'll factor a negative out. Make sense? If the finishing box is negative, you factor a negative out. Then if we go the other way, if I factor up like that, what's in common?
The x.
And the finishing box is positive, so it'll just be a positive x. Over here, what's in common?
12.
And the finishing box is, so we'll factor out a negative 12. And you can see our factorings here, x minus 1 times x minus 12. We'll want to write our answer like that.
Yes.
Okay. So, it's the second time you've seen that. You're starting to see some success. That's fantastic. Let's move on to numbers 3 and 4. So there are some more negatives in numbers 3 and 4. You are right. 4 might be a little funky. Don't stress too much about 4 yet, unless you have time to get to it. Really focus in on 3, and we'll get 4. We'll get 4 also, I think. What kind of an expression is number 3? It is a quadratic. So for a quadratic, we're going to do a 2 by 2 box. Lead term goes there. C goes there. The way that you figure out the other 2 boxes is you come off to the side and you figure out A times C. What is A times C? At this point, some of you might be saying to yourself, gosh, why do we even bother with A times C? Let me just remind you, in the future, like tomorrow, A will not be 1. And so AC will be a little more complicated than just 1 times whatever. Okay? All right, so then, gosh, there's a lot of numbers that multiply to be negative 18, right? So how about this one? Negative 2 times 9. There are others. What else would you suggest? Negative 6 times 3. How about negative 3 times 6?
Yeah.
Some of the ones that people forget about a lot would be these. Right? Sometimes people forget that 1 times anything is itself, right? Anything times 1 is itself. And there would also be negative 9 times 2. I think we got them all, right? So we go through and we ask ourselves which of those actually adds up to be the B. Well, this adds up to be 7, so that's not it. And look, our second one works. So it's not always going to be the last pair on the list. Sometimes it might be the first or second, and that's okay. So what I'm going to do is write negative 6x and 3x. Have you guys picked up on the idea that it doesn't really matter where you write those two? As long as they're just diagonal from each other? You put them in either one of those boxes. Factoring this way, what's the common factor?
3.
Yep, positive 3.
Yeah.
Factoring this way, what's the common factor?
X.
You guys okay with that? Okay, now factoring the other direction, up now, what's the common factor? It's an x. Now the other one's a little tricky. What's the common factor? Remember, it's about that finishing box. So it is negative 6. So you'd write it out as x plus 3 times x minus 6, and that would be that.
But those can be opposites.
Sure, yeah, you could have x minus 6 times x plus 3. Because multiplication is commutative, the order doesn't matter. Yep, that's a good point. Okay, so the other one was a little bit of a challenger, and in the interest of time, maybe I'll just show you the answer, and we can do a little more exploring with this tomorrow. That's okay? So if you got this today, that's great. If you didn't get number 4 today, don't worry, don't stress, please. We'll do some more of these tomorrow. We'd have an x here and an x here, and it would be plus 7y minus 2y. X plus 7y, x minus 2y. The y, like if the y's weren't there, this would be real straightforward, like number 3 perhaps. Like I said, if you got that, that's fantastic. If you didn't, please do not raise your stress level. We'll do a lot more of these tomorrow. Yeah.
So if you have a y on that last variable, the c value, you just write it in the box.
Oh, darn it. You know, hold on. Actually, there's a typo. And I just like, it should, if this was going to work, it would need to be this.
Yeah.
There's a typo.
But that's
You know, and here's the thing. Obviously my eyes just skipped over it, right? Because like I read that in there even if it wasn't there. Do you want to know how I caught it? Like while I was talking to you guys, I was like mentally just double checking it. And my last part of my check was 7y times negative 2y. Ooh, it should be y squared. Look at that. There's a typo. And so a lot of you were doing that double checking. That should give you a big hint about whether you've done it right or wrong. So anyways, sorry about the typo, but we'll practice a lot more of those tomorrow. So, all righty. Let's get your tables all facing the front. Get ready for your quiz.